there's two proofs. That's typical of well, it's the nature of IFF, if and only if type proofs, right? So you start with this, and you have to prove this. Now, so Q, what are you trying to prove? Well, you're trying to prove that two sets are equal, right? You know, this set here, the intersection, is equal to A. So how do you prove two sets are equal? Well, we did that in the theory part of the lecture. To prove two sets are equal, you have to show that one is the subset of the other, and the other is the subset of the one. Okay, so in proving if P then Q, we have to prove Q. Proving Q is going to involve two parts. So this whole question is going to involve like 4 parts, right? These 2 parts, both of them split into 2 parts. So 2 times 2, we have 4 parts in this problem. So non-trivial. Okay. So we start with P, and we have to derive Q. Now to prove Q, we have to show these 2 sets are equal. And how do you do that? You show that one is a subset of the other, and the other is a subset of the one. Right? So we have to show that one is a subset of the other, and vice versa. Now how to do that? Well, let's say X belongs to this one, the intersection. So X belongs to the intersection. All right. Now, if X belongs to the intersection, that means X belongs to both A and B, right? By definition, that's what the intersection is. So that means that X belongs to A. Okay? So if X belongs to this, X also belongs to A. Now, that's the definition of a subset, remember? So that means this intersection is a subset of this, right? So we have that. So the intersection is a subset of A, all right? Now let's go the other way. So let's say X belongs to A, right? Now if it belongs to A, X belongs to the union. Okay, that's the definition of the union. The union can take elements of A or B. So if X belongs to A, X belongs to the union of A and something else. Okay? Now, we know that A union B is B. We're told that. We're given that. That's P. We start with P. Right? We're trying to prove Q given P. So if X belongs to A union B, we know from here that A union B is B. So we could replace this just by B. So X belongs to B. Right? So if X belongs to A, X belongs to B. Right? Both. So if X belongs to both of them, then X belongs to the intersection, A intersection B. Right? So if X belongs to A, X belongs to the intersection. So that means that A is a subset of the intersection. There it is. Okay? Now I've wiggled it. Here we show the intersection is a subset of A, and here we've shown that A is a subset of the intersection. So we've got these 2 parts now, put them together, and the only way they can both be true is if A union B equals A, and that is Q, right? That's Q. We've proven Q. So we've now solved half of the problem, and by solving 2 sub-problems, so to speak, or sub-sub-problems, because there are like 4 parts in this question. All right, now let's go the other way. So now let's solve the second half of it. So we now go from Q to P. So you start with this, right? So the intersection is A. You start with that. Here it is. Intersection is A, and we have to prove P. Right? So we're going from Q to P. Q to P. And again, how to prove 2 sets are equal? By showing the one is a subset of the other, and the other is a subset of the one. So again, the same 2 parts. So, all right. So let X belong to this union. So X belongs to the union. So that means X belongs either to A or to B. Right? That has to be the case. X is either in one or the other. If it's in neither, well then X doesn't belong to this union. So it has to be in, X has to be in either A or B, right? X belongs to A or X belongs to B. Okay, so let's assume that X belongs to A, right? Now you're told, because it's here, this is given, this is what you start with, you're told that the intersection is A. Okay? Now you know X belongs to A, well you've supposed that. So if X belongs to A, X belongs to the intersection, right? Because the intersection is A. Right? So if X belongs to A, which is that, therefore X belongs to that, because these two are the same. So X belongs to the intersection. And if X belongs to the intersection, X must belong to both A and B. So X belongs to B. Right? Now we had two possibilities here, right, with the or. So either X belongs to A or X belongs to B. Now if X belongs to A, we've just shown X belongs to B. So if X belongs to B, either way, X belongs to B. Okay, so either you derive it using this, or it's just given. Right? You just this. All right. So either way, X belongs to B. All right. So if X belongs to the intersection, then X belongs to B. Now that's the specification for a subset definition. So that means that the intersection is a subset of B. Right? So we've now done our third of the four parts, in a sense. Okay, so keep that in mind for later. All right. Now let's try to go the other way. So you show that the one is a subset of the other, and that the other is a subset of the one. So now let's do the second part, in fact sort of the fourth part. Right? So now assume X belongs to B. Right? Assume X belongs to this one. And if X belongs to B, then X belongs to the union. Right? That's the definition of union. All right. So that means that B is a subset of the union. So B is a subset of the union. Okay. Now take that one and this one, and the only way those two can both be true is if the union is equal to B. So A union B equals B. Now that is what? That is P, right? That's P. The union is B. That's P. So we've now proven P. So we've now proven both ways. Okay? And having proven both ways, that's an if and only if type problem. If. And that means if from P you get Q, and if you start with Q and you derive P, if you can go both ways, that means those two statements are equivalent, right? So these two statements here are equivalent. So we've proved it. Okay, next lecture. So lecture 3 will be on binary operations, and that's an essential concept. What's lecture 4? What's lecture 5? So chapter 5, lecture 5 is on groups, so we need to go through the integers. That'll be chapter 4. So we're heading towards, we're acquiring the tools, the concepts necessary to understand the nature of a group. What is a group? A group is a special kind of set, but we need more tools. And the notion of sets is important. This kind of reasoning, not trivial, but to do this, we needed the knowledge from the first lecture on equivalence. Okay, so see you next lecture.